Welcome back as we now discuss types of lubricants. We've already learnt that the most commonly used lubricants are oil and grease. However, a very important thing for you to learn is that not all oils or all greases are the same. For example, these two oils, just by their appearance, look very much the same. But because of certain additives and processes in their manufacture, the two types are very different. Now, the only way that you would know this would be to read certain information on the manufacturer's label or container, which we'll go into shortly. When we look at greases, we find that there are many different types, and again, only by the manufacturer's label can we possibly know what type it is. You may ask, why do we have to have so many types of oil and grease? And the answer would be, because we have different machinery, different working conditions, and even different climates in which a lubricant must work. For example, to lubricate all the moving parts in an engine, which move very fast and are usually also very hot, we need to use oil that has been developed specially for engines. And not surprisingly, we call it engine oil. However, where gears are used to transmit power, the lubricant used is normally thicker than engine oil. Oils, therefore, are made in different thicknesses. The technical word for oil thickness is called viscosity. We cannot guess the viscosity of oil, but if we look at a typical can of engine oil, you will find the oil's SAE rating, like this SAE 30 here. The letters SAE mean Society of Automotive Engineers, and the number is its viscosity rating. In the SAE system, a low number is a thin oil. For example, this is an SAE 10 oil. You can see how fast it runs when it is poured. As the numbers get bigger, the oil is thicker, or as we say, it has a higher viscosity. Again, by example, you can see how an oil rated at SAE 90 flows more slowly than an SAE 10 oil. Now we must explain something interesting about lubricants. When oil or grease get hot, they also get thinner. To prove this, we've heated a sample of SAE 40 oil to around 90 degrees centigrade. In our other container, we have SAE 40 at normal room temperature. Notice that the hot oil pours much more quickly than the cooler oil. At the opposite extreme, here we've cooled some SAE 40 in a freezer. Now it pours quite slowly, proving that oil gets thicker when it is cold. An oil type known as multigrade, which has a grading or rating with a W in it, can operate or flow easily in both cold and hot conditions. Multigrade oils are mostly used in petrol-powered engines. A typical grade is 20W50, an oil that behaves or acts like SAE 20 when cold and SAE 50 when hot. Other letters that you will sometimes see on oil containers' labels are EP, meaning extreme pressure. Oils and grease bearing an EP rating are designed mainly for heavy-duty gears. Oil and greases are usually purchased in standard containers. Standard containers include 500 milliliter oil cans, 5-liter oil packs, 20-liter oil packs, 15 kilogram pails for grease, 50 kilogram drums for grease, 180 kilogram drums for grease, and 210-liter drums for oil. Every container must display the product name and product type or grade. It is this information that lets us know what lubricant is in the container. Where an oil container does not show an SAE rating, but simply a number, then it is an ISO rated oil, meaning International Standards Organization. ISO lubricants are mostly designed for heavy industry uses. After the break, we'll look at how we get to know what lubricants to use and where.